Let us now talk about how aldehydes and ketones are prepared, right? So first and foremost, if you remember our discussion on chemical reactions of alcohol, you will recall that alcohols get oxidized to prepare aldehydes as a. You remember we discussed that if a lot of concentrated sulfuric acid is used, they get further oxidized to carboxylic acids as well, right? So let us see how this oxidation of alcohols takes place once again in this chapter. So let's see how oxidation of alcohol happens. So when this oxygen atom from an oxidizing agent comes and attacks the alcohols, this water molecule gets separated and this is what we get, RCOR, right? Now, what kind of an alcohol it is? Is it a primary alcohol or a secondary alcohol? How did we use to identify that? This is the OH group, that is the alcohol group. This OH group is attached to a carbon atom that is further attached to two more carbon atoms. By R and R dash we mean two different alkyl groups, right? So the hydroxyl group is attached to a carbon atom which is further bonded to two more carbon atoms. We call them secondary alcohols, right? So you can clearly see here, if oxidation of a secondary alcohol happens, we get a ketone, RCOR. Right? Now what if it was a primary alcohol? We would have gotten hydrogen over here, so we would have got RCHO, which is a aldehyde. So oxidation of primary alcohols gives us aldehydes, whereas oxidation of secondary alcohols gives us ketones. Let's see this. This is a primary alcohol. We oxidize it in the presence of an oxidizing agent and we get an aldehyde. In case of secondary alcohol, we get a ketone, right? Now, where did this oxygen come from? From an oxidizing agent, right? Can you name any oxidizing agent? Well, the commonly used oxidizing agents in preparation of aldehydes and ketones are acidified potassium permanganate, right? Its formula is KMnO4. And do you know how it looks like? It is in the form of black crystals. Another oxidizing agent used in the process of oxidation of alcohols is potassium dichromate, right? K2Cr2O7 is the chemical formula. And any idea what this compound looks like? It is bright orange in color, right? So these are a few examples of preparation of aldehydes by oxidation of alcohol. I am using potassium dichromate with dilute sulfuric acid to provide oxygen to alcohol so that water can vent off and aldehydes can be prepared, right? Then to prepare ketones, same thing. The only difference is when ketones are prepared, oxidation of secondary alcohols is done. When aldehydes are prepared, oxidation of primary alcohols is done. We can see this is a secondary alcohol, right? The hydroxy group is attached to a carbon which is further attached to two more carbon atoms. So this is a ketone preparation from a secondary alcohol. Okay, we must keep one thing in mind, as I told you earlier, that alcohols immediately go further oxidation to carboxylic acids also. So, we have to perform this reaction under controlled conditions, as in we should stop providing more acidic medium. So, when ketones or aldehydes are prepared. Next method of preparation of aldehydes is dehydrogenation of alcohols. So we have a propyl alcohol over here. When passed over copper at a temperature of 300 degrees Celsius, we get propanol.